Is Group Three's final deliverable with Tony Christensen, Mark Hall, Christy Hornland, Taylor Jorgensen, and Hao Tran. The purpose of our BI system is to have a restaurant system in place to monitor inventory and shipments, to have a business process of inventory management, to establish a system that can check reliability of vendors and vendor relationship management, and to gain an understanding of costs of defects and the rate of defects over time for improved business practices and efficiencies. Our decision makers' needs are timely and accurate delivery of data regarding inventory and shipment needs, information that helps the restaurant make better business decisions, and a tracking capability of vendor performance. Inventory fact measures. Some of our fact measures are defects, which identify whether or not an item has a defect, costs, such as the cost of a certain item. Some of our calculated measures are percent rejected, which is a calculation of total defects divided by total inventory, and accepted inventory count, which is a calculation of inventory count minus defect count.
Our shipment fact measures include defects, which identifies whether or not an item has a defect by 0 or 1 as a numerical value, rejected orders, which measures total rejected orders, tardiness, which counts the days tardy from the expected order arrival date. Then we have two calculated measures, including percent on time shipments, which is calculated by total shipments on time divided by total number of shipments. Then we have vendor accountability, which is a total of all days in tardiness column for one particular vendor divided by 365 to see an average tardiness of a vendor. Both calculated measures provide more value to an end user when more data is collected. The end result should be a quick and effective measurement of whether a vendor has proven themselves to be dependable by the restaurant. If a vendor is continuously providing rejected shipments or lacking punctuality, it's time to revisit the relationship with the vendor. Moving on to dimensions, our dimensions are as followed. For date time, we have date time to week, to month, to quarter, to year. And for restaurant, we have from restaurant to city, to county, to state. And then originally for inventory item, we had inventory item to prepped item to menu item. However, after regarding our grain, we look back and revise it to remove the menu item from the list. As if an inventory item has spoiled, there's no way that it would be put into a menu item. Then finally, we have order, which is order to vendor.
As you can see, we've made some changes to our schema. In the last deliverable, our schema was separated by shipment fact and inventory fact into their individual schemas. In this one, we've connected both shipment fact and inventory fact into one schema. The reason is the only difference between shipment fact and inventory fact was that both the subcategories contain dim restaurant and dim date time. The only difference is shipment fact contains dim order, while inventory fact contains dim inventory, and further down the hierarchy.
Hello, I'm Mark Hall, and I'd like to take this opportunity to give you a brief demonstration of our live business intelligence cube. Let's go ahead and open things up here and take a look at the cube structure. Because this is a working prototype, we are going to make changes to the structure prior to our release to our clients. First change we are going to make is going to be flattening the dim inventory dimension. This is because we have lost the integrity of our grain by expanding out all the way up to menu item for the inventory fact. As discussed earlier in our dimension analysis, we do not need to track anything above the inventory item just because of the many-to-many relationship that inventory items have with menu items. So that will be our first change. Also, we included a physical schema for our dim date time dimension. We will not be using this schema with the release. This is because it is a lot easier to virtualize the process of capturing the date time. We also want to make sure that our end users understand how to use the cube effectively. Because we have two fact tables, there are specific dimensions associated with these fact tables. It is important that the users understand the relationships that occur between them. First and foremost, shipment fact has a unique dimension, the dimension order. Inventory fact has its own unique dimension of dimension inventory. When end users try to put these two dimensions together, the results won't give them anything useful, so it's important that they understand that. Alright, let's go ahead and jump into the browser and start playing around with things from two different perspectives. Because we're offering both an inventory fact and a shipment fact table, we want to give upper management an opportunity to look at both aspects of the business. Let's first approach this from the inventory fact and put out a couple measures here. You can see that we have two calculated measures in the inventory fact measurement group. This is accepted inventory count, which is just the total inventory fact count, and subtracts the defect of inventory. This gives them a true count of what inventory they have on stock. So we put that out there, and we also want to put out percent defected inventory. With those facts now out in the cube, we also want to put some dimensions against those. I believe date time is always a useful metric. So let's go ahead and put the date time in the columns, and the row fields, let's go by inventory. So you see here, this is the change we want to make. The menu item ID is the top level of the hierarchy, and we want to flatten that all the way down to the core components, which are the inventory items. This is because of the many-to-many relationship that exists between a menu item and an inventory item. So from a manager's perspective, you can see that they can know the accepted inventory count and the percent defected inventory. If they want to get down to the base measures, we can go ahead and put the inventory fact count out there. And this will show the calculation of a 50% defective inventory out of 2 inventory items will give them an accepted inventory of 1. I'm going to go ahead and clear out the cube, and I'm going to put some shipment facts out there. For shipment facts, we have 3 calculated measures. We have percentage accepted, which is just accepted over total shipments, percentage rejected, which is just 1 minus percentage accepted, and then finally vendor accountability. This calculated measure, as explained earlier, shows how many tardiness days a vendor had within an entire year. So I'm going to go ahead and put vendor accountability out. I'm going to put out percentage accepted, and finally I want to look at the defects. Again, I'm going to put date time for the column fields, and then I want to go with the dimension of orders. And this is a 2-step hierarchical dimension, which includes the vendor, and then finally it includes the order ID. So any manager can tell based on which order, which vendor it came from, and finally if it had any defects, if it was accepted, and then finally the overall accountability of the vendor the order was originating from. That about sums up our live demonstration for our BI cube. Taylor is now going to give a brief overview on our reporting system. Thank you.
Alright, so I'm going to go ahead and go through some of these reports. So our first report is an inventory defect report that basically just shows by year and quarter the specific inventory item and its cost, and then if that specific item had a defect, that allows you to see the cost of the defected items, see how much waste you are having. So as you can see, we have a bar graph to go with that. We can see lettuce was a little less than $20, shrimp's pretty high up there, and shrimp was actually the one that had a defect, and that's a pretty big hit to the company in terms of cost. So if I scroll down a little bit, then we've got the defect by vendor, and that's going to go ahead and show which vendors we got defected products from. And if I go to the next few pages, it just shows it by region in addition to by the restaurant, so that you can see how the regions and restaurants are doing in terms of defects and costs. And now I'll go ahead and go back so we can look at our next report, shipment report. It's just taking a second to open. Alright, so here we've got our shipment report. In this one, we've also got year and quarter. We felt that these were good standards to look at. And so this one shows you how many shipments we've actually received for the specific restaurants. So for the Eastside Bar and Grill, as you can see, we've got 2 shipments in. One of them was defected, and that gives you a percentage rejected shipments of 0.5 or 50%. And as you can see, even though the Q1 shipment, the first one right here, even though that did not have a defect, it was still tardy 1 day. We just want to display the tardiness and the percent rejected so they can get a good idea of which shipments were not meeting standards. And we have a graph here too showing the percent rejected on a quarter by quarter basis. And the further parts of the report display the different restaurants and their results.
So for our lessons learned in this course, in order to create the date-time dimension, we use T-SQL instead of creating it manually. Secondly, we should allocate more time efficiently. More detail is better, harder to achieve under time constraints. Generally, for reports, we like to have as much data as we possibly can. Another thing is the technical skills in this course are not very hard, but neither is intuitive. In order to retain all of the information and be useful in group projects, we should attend all classes and do all in-class assignments. Also, another thing is for group meetings, we should always have an agenda for what will be discussed and what issues would need to be solved during meetings. Lastly, for difficult roles in group deliverables, we should rotate the roles so all members can have a good learning experience. Realistically, in a real-world work experience, team members will usually perform their respective roles. For the purpose of this project, everyone should divide work so that everyone can learn the material.